We are really excited to start with our first webinar. As you know, or many of you here probably know, we launched the community of practice recently, and this is the first activity that we are organizing. You can move to the next one. So the APRICOT project is a project mainly focusing on improving tools and resources for ontologies in behavioral and social sciences, and also a project focusing on developing new ontologies and parts of the behavior change intervention ontology that we started to develop as part of the Human Behavior Change Project. So the project is coordinated by Susan Miki, who might be here today, also attending the webinar, and myself and Janna Hastings are co-investigators in this project. And Paulina, Carolina, and Michaela, who are also here today, are research fellows in the project. So as part of the APRICOT project, one of the main initiatives is this community of practice. And as part of the community of practice, we are launching for the first year a series of activities. So we are doing various webinars. You can see here in this calendar that we will also share at the end that we already have 4 webinars planned until the end of the year. So the webinar today, one in June, focusing on the behavior change technique ontology. So I'll be delivering that webinar. We have another one in September that will be delivered by Robert West, focusing on the paper and protocol authoring and annotation tool. And another one in October, date to be confirmed, looking at how to annotate intervention reports using the behavior change intervention ontology. Then we are also going to be developing other initiatives as part of the community of practice. So we'll be doing a spotlight event. This one will be led by Michaela Santilli and will be focused on a project called the Galenos Project that Janna, Michaela, Susan, Miki, and other colleagues here are part of, that is really focused on developing ontologies for mental health interventions. So this is going to be a really interesting session for those of you that work in this area. We're also doing a workshop, so practical hands-on session on annotations using the behavior change intervention ontology with colleagues and researchers that have experience in using the BCIO for annotations, and they will talk about procedures and challenges and share their experience. And in July, we're also going to have the first Ask Me Anything session. So myself, Carolina, and Paulina will be available to answer any questions that the members of the community of practice might have about ontologies, and we'll be available for that. So these are the activities planned for the first year. We will, of course, appreciate if you can send your suggestions for activities, if you can send us feedback on the different activities so that we can improve and adjust what we are doing as part of the community of practice for your expectations and your interests. And just a reminder before we kick off the webinar today, that you can go at any time into the community of practice and chat with other members, introduce topics, and soon we will also be introducing the first activity of the working group on 24-hour movement behaviors, in which we'll be asking the COP members to provide feedback on the ontology of physical activity and the annotation scheme that we are currently developing. So, Johnny, you can move to the next slide. So with no further ado, I'm introducing Janna Hastings, as I said, a co-investigator in the APRICOT project. Janna is a senior researcher at the ADAP Research Institute in Switzerland, and she leads a research group on human-centered AI in the health domain. And Janna Hastings is a wonderful colleague and an amazing researcher with really, really extensive knowledge on ontologies and on the application and development of ontologies for behavioral and social sciences. Maya Brown is a research fellow in the APRICOT project who couldn't join us today, but she worked on developing the presentation with Janna. So Janna, the floor is yours. You can go ahead. Thank you. Oh, sorry, I forgot to say something that I was asked to say. You can ask questions at any time in the Q&A box, and at different times of the webinar, we will stop and see what are the questions and discuss any elements. So please feel free at any time to post your questions. Thank you.
All right. So thank you, Marta, for this amazing introduction and for kicking us off today. So I hope that I can see that there are participants, but I can't see your faces or anything. But I hope that this today's introduction will reach the right level. And I really encourage you to ask your questions to allow us to use this opportunity in a kind of conversational way to really get to reach you where you're at with the questions that you have. So I'm going to kick off. As Marta said, Maya was very unfortunately not able to join us today. So it's just going to be me doing the presentation, but I will refer in some places to work that Maya has done and hope that I do some sort of justice to her work. So this is just our introduction slide. So we'll kick off now with our introduction to ontologies for the behavioral and social sciences. And for those of you who have joined previous webinars, this one is really starting again from the beginning. So excuse us starting from the beginning, but there are some people who have never joined any webinars before, and we're hoping to start with the all-important question, what is an ontology and why should you care as a behavioral and social scientist or somebody who is using behavioral methods in your practice? What is an ontology, this obscure word, and why should you care about it? Might be a question that has come in your mind before. So ontologies are a very, I think, interesting phenomenon because they are, on the one hand, a very computational thing. They represent knowledge, they use computer languages to do it, they sort of have a very structured format and representation, and they have this aspect of being computational resources. But on the other hand, they are also very human and social objects because they bring together a bunch of humans to sort of decide what should go into them, and whole communities are built up around this kind of conversations of how do we put what we put into the ontology and how do we structure our content in our domain. So with that in mind, sort of having this dual aspect of the human aspect of the ontology and the computational aspect of the ontology. Um, this is what we can say that they are. Ontologies are structures for representing knowledge. Some people prefer to say they represent entities rather than knowledge. This distinction is subtle, but it matters because we sort of can use ontologies to discover new things. So they don't just represent what we already know, but sort of serve as tools with which we can make new discoveries and grow our knowledge. So inside the ontology, we can put classes. Classes can represent anything, anything that exists in the universe, anything that we can conceive of or study. We also can include defined relationships between classes. So you have this very schematic illustration on the right-hand side of your screen there. We include, and it's really important that we do a good job at representing the properties of classes, like what they are, what sort of attributes we care about each class. And this sounds quite abstract now, but we will get to examples in a bit. And then each class that we put in the ontology is given a label, a definition, and a unique ID. And this is really the heart of sort of how we use and build up these resources that we can use for standardized and structured applications, because these unique IDs allow us to make coherent data annotations in ways that are not confusing, even when the language that's used to describe the domain is confusing. And the labels allow us to make the classes sort of understandable to humans, and the definitions allow us to be very clear about what it is that we're trying to talk about for each class. So this is the meat of constructing an ontology, is giving or deciding on frameworks by which we can assign good labels, good definitions, and a clear system of identifiers, and then manage those as the ontology evolves and grows as we add more and more content to it. A really key part of ontologies is the fact that they're arranged into hierarchies from the general to the specific. So that's kind of what you would intuitively understand. You have broad classes which cover a lot of different things, like you could say human being, that's a very broad class. And then you might have more narrow or more specific classes. So for example, you might have a class just for female human beings, or you might have a class just for adolescent human beings. And these are sort of hierarchically arranged beneath the broader class of human beings. Okay. So there could be a huge number of different examples, and later on we will focus more specifically on behavior change related examples. But for fun, here's an example that represents some aspects of the domain of movies. For example, what the genre of the movie is. You could have comedy movies, you could have thriller movies, and notice the representation of the hierarchy here. On the other hand, you might have an ontology for the domain of mental processes, right? So thought, matter, or mental processes are not out of scope. They're absolutely in scope for ontologies. People study mental processes. People write whole theses about mental processes. So we can also have ontologies about mental processes. And here you have a very simplified schematic of a potential ontology in which motivation, learning, and two different types of learning have been classified. So these are very lightweight schematics. They don't have some of these attributes that we talked about before, like showing this sort of distinction between ID and label. This is not represented in this visualization. We also don't see listed here in this visualization what the definitions are, but it's intended to be schematic. We also don't see other relationship types other than this hierarchy relationship, which is called ISA. But yeah, these diagrams can quickly become very difficult to sort of get a good overview of. So this is where we start with simplified visualizations, and you can imagine all the rest. A class in an ontology. So each circle here is an example of a class. And a class in an ontology can really be anything. Can be a movie, can be a pizzas. Pizzas shows up because one of the most famous tutorials on how to create and build ontologies is oriented around an ontology of pizzas. So like before anybody learns how to do their own domain, they learn how to build ontologies for pizzas because that was the sort of famous introductory tutorial on ontology building, giving examples, and it had like examples about, I don't know, pizza with cheese, pizza without cheese, pizza with other things added on top of it. And you could do all sorts of reasoning on this pizza ontology. So that's why it always shows up as an example by now. Learning could be a class, a person. We've already talked about different types of human. Identity. So this is a kind of more abstract concept, but it can also be a perfectly valid class in an ontology. Age, which is sort of an attribute that can be held or related to individuals. Complex composite classes such as imagination process. You could have even more complicated names for classes. So just to illustrate that they don't all have to be just one word names. And relationships. So we talked about relationships. We talked about the subclass relationship, but you can have other types of relationship as well. A relationship sort of captures a way in which two entities belonging to two classes are related to each other. And in the OWL language, we talk about object properties. So an object is a member of a class, and the properties that relate objects directly, they're called object properties. And you will see in a second that we also have other types of not object properties, but what are called data properties. And it's important to have this distinction in mind for the OWL language specifically. I haven't actually introduced the OWL language, but the OWL language is one of the main languages in which ontologies are represented for the computer. So that comes back to this question of representing content in a structured way that a computer can work with, and we have to fit the content into the right sort of framework. So the R language is one of those frameworks. Okay, but for examples you have here, for examples of relationships, Hannah is sister of Abby, so family relationships can be ontology relationships too. Who knew? Abby likes pizza, so preference relationships. Pizza has topping cheese. That totally comes out of that tutorial that I mentioned earlier. Questionnaire measures construct. So this is a really important one for the behavioral sciences for sort of the measurement domain. And this kind of measures relationship is something which we really hope to capture and start to formalize, because it can be very tricky to infer sort of from published papers what exactly were the constructs that researchers were intending to capture with a particular questionnaire or instrument. Motivation influences behavior. So this is an example of a relationship which is maybe context dependent and not as sort of easy to determine in the real world empirically, but we have to work a bit harder to figure out if this kind of relationship holds or not. In this case, I guess it's fairly well established that motivation influences behavior, but nevertheless, in order to determine in a particular instance empirically, may be quite tricky. Okay. A property can be any value attached to a class. So here we're not talking about relationships between objects or members of a class, but rather the attributes that we want to ascribe or capture about members of a class. And these kinds of information are represented often in a way that you sort of have a value range which makes sense for the property. And a particular individual might take a value from within that value range. So we can capture both of those types of information in the ontology. We can capture the class level value range, which makes sense for that property for that class. Like, what are the sort of reasonable values for a human age, right? And actually, then you can sort of do some error detection in your data set if you've used the ontology, because you can pick up that, well, it's very unlikely that a human was 300 years old, for example, which, by the way, is a value that is relatively frequently used in medical data sets as a way to indicate that or obscure the actual age. Some sort of wildly inaccurate number is then put in as a flag to say, well, there is an age, but we don't want to say what it is. So we're going to use this other number. But an ontology could have rules which sort of picked up that case. So in the OWL language, we call these value capturing properties data properties. And here are some examples. Questionnaire has number of items 10. So this might let you do some sort of reasoning or filtering with how many items you want to show in some aspect of your data capture workflow. Response format is choice true. Person has name Hannah. And other literals, other string values or attributes can be captured as well. So it's not only numbers and booleans, you can capture string values as well. Okay, so having given the whirlwind tour of the basics of what you can put into ontologies, you might now be asking yourself, why would you want to do this? Why would you want to sort of start to capture knowledge, define all your things that you care about in your domain, and so on? So one of the real motivations or benefits of using ontologies is that it allows you to define a shared vocabulary. And one of the reasons we want to have a shared vocabulary, a sort of community-wide agreement on a certain vocabulary, it's not to be the vocabulary police, it's so that we can put together and integrate evidence which arises out of distinct sources. And this is really challenging if you only use text, which is unlinked to any kind of structured standard, because people can just use words in different ways, right? This concept of jingle jangle fallacy, sort of sometimes things can be meaning the same thing, but people use different words to refer to them. Or another time, things can be meaning different things, even though different researchers have used the same term to refer to them. And it can be very difficult, or we all know that it is very, very difficult to integrate evidence across studies and to really put together a big holistic picture of what we sort of know about challenge in this domain in the behavioral sciences. And we have some kind of silos which are driven by this lack of a shared vocabulary. So our objective is to be able to put everything together into a bigger picture. It's not to force anybody to use a vocabulary they don't want to. It's to just make it possible to put things together into a bigger picture. And another benefit of using ontologies, which relates to the fact that they are computational resources. So the previous one was almost more of a human benefit. This one is more of a computational benefit, that with the knowledge that you can put in ontologies together with sophisticated algorithms, you can unlock automated reasoning and automated error detection, which is a great something great that people would benefit from if they would be able to use it and to access it more easily. Okay, so for example, you might want to flag problems, automated detection of key problems in a research design, or you might want to make recommendations, such as recommending support for researchers. Which questionnaire should I use to address measurement of a particular construct? Which research design should I use? Which intervention is appropriate? Or even direct to patients, e.g., which exercise should I do if I want to achieve this outcome or this goal? And all of these kinds of inferences that are enabled by ontologies are completely transparent, because it's a link directly from the knowledge or the structure that you've created in the ontology to the recommendation or the output. It's not like our modern sort of language-based AI, where you could have recommendations, but you don't really know on what grounds they are based. So transparent AI. Ontologies are a form of transparent inference once you've captured the knowledge. Okay, so this might be a good moment if anybody had any general questions. Before we start talking about specific, we've got this two use cases, evidence synthesis and recommendations.
We don't have any questions submitted online yet, but now is maybe a good time. If you have any questions to please just submit them, and then we can get basically address them throughout, so that, and there's no too small question. We know that ontologies can feel sometimes quite complicated, so any questions are really very welcome.
Yes, remember that this is your opportunity to dive in and ask those questions as they come to your mind. Okay, so in that case, if there's no question right now, I'll keep going on the case study of using ontologies for evidence synthesis. So before we start, just to say that the motivation for the concept of using ontologies for evidence synthesis comes from the biomedical domain, where, for example, the gene ontology, which has been running and being developed for more than 20 years by now, has really had a dramatic and field-changing impact on the study of especially the functions of genes and gene products. So for those who don't know, gene products might be RNA or proteins, those kind of things. And their functions might be, well, what do they, this particular gene helps it helps in the process that synthesizes sugars out of something else. All these kind of biological things that our proteins and the rest of our biological equipment do. And in the early days of molecular biology research, each kind of research community had their own vocabulary for all of these kinds of functions, and they had their own databases for the genes of interest that they were studying. But of course, in order to build up a sort of overview of the whole of the landscape of the genome and how all of the different species are sort of related to each other and all of these molecular processes, the task is huge, and it simply requires exchange and synthesis of the results of many, many different experiments. So the gene ontology was created in order to provide that shared vocabulary. And it has been heavily influential. The original paper reporting the gene ontology has been cited by now more than 47,000 times. I think this was a few years ago. I used to present the gene ontology paper, the number of citations alongside the number of citations for the paper reporting on the original mapping of the human genome. And by now, the gene ontology paper has been cited more than twice as many times as the paper reporting on the original assembly of the human genome. So that just gives you an idea of the sort of scale and scope of the impact of this tool in molecular biology. And most importantly, it enabled this sort of synthesis and integration of knowledge from across different studies by creating this massive shared vocabulary, which then accelerated the pace at which this field of research could advance. So in the behavioral and social sciences, similar efforts at that scale have not yet emerged. And there was just a few years ago a report by the National Academies of Science, Engineering, and Medicine, which essentially called for the emergence of similar approaches which were able to sort of really scale and integrate knowledge and accelerate research in the social and behavioral sciences. Here is the report and the recommendation. The main recommendation of this study was that ontologies should be developed and adopted within the social and behavioral sciences at a much higher rate in order to address ongoing and persistent challenges which the field was facing, and in order to allow for ultimately easier sharing and exchange of definition, classification, in order to allow for communication, data integration and sharing, and ultimately evidence synthesis. So here's a schematic. So about the problem of evidence synthesis in behavioral science and how these problems are addressed by ontologies. So as many of you may know, in the social and behavioral sciences, there is a large amount of research being published. For example, in the field of behavior change interventions, there are approximately 100 studies per week published. This was a paper which Susan Mickey and Robert West published a few years ago, which estimated this number. It's probably increasing over time. Most fields of research are having a somewhat increasing trajectory in number of publications. So the problem is not getting better. And I'm personally not able to read 100 papers a week. Even if I could read them, I wouldn't have time to do anything else. But it's not only the amount that is kind of staggering, it's also how what we can do with those amounts. So for example, when the papers use incomplete, when they report incompletely, it means we sort of miss information. Maybe in order to figure out what exactly was done, we have to go back to the original authors. Maybe the reporting is ambiguous and it's difficult to determine exactly what was done, or maybe the categorization is confusing and it doesn't match up with how another study has categorized their intervention or what they have done. So even if we could process all of those articles, we're still sitting with a kind of messy picture. Here are some more detail about this problem of incomplete and ambiguous reporting. So methods described in vague terms. This is a challenge for across all of scientific research. It's really important to be very detailed and specific about the methods that are used in a study. And there are a range of reporting guidelines which aim to make those methods more specific and perhaps specific enough to be reproducible. But it's one thing to be specific and clear, and then it's even better to be specific and clear in a way that is kind of agreed so that you can put together the results of different studies. And then you have as mentioned before, this jingles and jangles. Here are some examples. Same term used to mean different things. Stress, great term, means 1,000 different things in different contexts. Of course, we have to get much more specific and be really clear about what we mean when we're reporting something in the scientific research. Different terms used to mean the same thing, perceived behavioral control versus self-efficacy. And these problems can be solved by being explicit about our definitions. It's not necessarily about using the same words. In the end, the answer is not to force everybody to use the same words, but to force everybody to agree on which definition they mean when they use a certain word. And that's what we mean by creating a kind of shared vocabulary. It's about the definitions being sort of agreed on. And then in the end, being clear about which definition you are referring to, which is why we have this concept of IDs in the ontology so that you can call out the particular definition you wanted to refer to by attaching it to a certain ID, and that's regardless of sort of label. All right, so the solution is a shared language to the problem of incomplete and ambiguous reporting. The other problem of there being too much to do, too much to read, too much to process. This applies not just to published literature, by the way, it also applies to kind of data, aggregation, data collection, depends what sort of task you want to do, but there are some forms of data which are also accelerating at a really rapid pace. Social media data, for example, some studies depend on social media data, and there's a massive volume and an increasing of that as well. So in terms of publications, as I mentioned, this estimate of at least 100 publications on behavior change interventions every week. It's not feasible to keep up as an individual researcher. However, if you have some sort of automation strategy, then you can keep up. So the goal of automation is to do something in a trustworthy way, in an automated way, which improves the situation. So putting together ultimately some of the overviews that we want to have about what's being studied and what's being reported and how do we get an integration of it. If we can automate some of that work, then we can keep a handle on these 100 papers every week. But we don't want the automation to be completely out of our control or black box for obvious and non-obvious reasons. So one of the problems is that these kind of black box algorithms, they might work in a biased way, but because we don't have transparency about the methods, ultimately about the connections that they're using under the hood because of this black box problem, without that transparency, we can't tell in a principled way if they're working in a biased fashion. We can only observe sort of after the fact or by doing tests, we can observe biases empirically, but we can't discover problems without sort of thinking, oh, let me check if it's biased in this way, let me check if it's biased in that way. So the black box problem is a problem that sort of should concern us, even if we think that algorithms, black box algorithms are, a part of our everyday life. And I've had some people say, well, why would we expect to understand what the computer is doing? If it's doing a great job, we don't care. That might be, but it very often could be manifesting biases. And we want that transparency so that we can check and be sure in a principled way of what the algorithms are doing. Okay, so we want automation, but we also want transparency. And ontologies can help. They can work together with other algorithms, but they can give us that transparency. And that's one of the reasons why we build them, or we try and inject them into all of these automation processes. Okay, so amounts too large to process for individuals, solution automation, and both of those, the shared language and the automation, lead us to the objective of building an ontology. Okay. Ah,
Hi, sorry, I'm coming in as question master, but
yes.
we do have some submissions now. So the first one is by Stephen Devick. I hope I'm pronouncing your name correctly. But the question is, what types of things do people attempt to apply ontologies to that are not a good fit?
That are not a good fit for ontologies to be applied to? This is a great question. So I think one of the things that we could say here, I mean, there's probably a whole research study hiding behind that question, but one of the things that we could say is that ontologies are for clear sorts of definitions and things which we cannot define and which are completely not clear to us as researchers or to people who have to work. It will also not be easy to put them into an ontology. So you are forced by the sort of task of coming up with clear definitions and arranging everything in a hierarchy and fitting it into a knowledge structure. You're forced to become clear about what you mean. And there are many fields where a sort of strategic or targeted ambiguity has been part of the practice for a long time. And in these areas, when this sort of strategic ambiguity is surfaced by an ontology development effort, there can be some resistance to pinning things down in the way that you are required to. That's not a concrete example. That's sort of more of a feeling for when it works and when it doesn't, but maybe it gives a hint in the direction of when this will not work so well.
Thanks, Janna, and thank you for the question. That was a really interesting one that I hadn't heard before in the webinar, so that's great. Next, we have Rachel, who submitted a comment saying, I'm so fascinated by the jingle jangle fallacy. I've encountered the effects many times before, but I didn't realize it had a label. At least I can name it now. So she's thanked you, Janna, which is great.
That's great. Yeah, I mean, I didn't know that term either. I don't know who invented it. We should do some sort of historical attribution there. It's definitely a term that comes out of psychology or the behavioral sciences in some form. But there's surely some hotshot of like 50 years ago who invented that, right, Paulina?
Yeah, that's correct. So I think it's used quite commonly nowadays in behavioral sciences, but I think it exists in so many domains. And I can't remember who coined it first, but I heard Mary Johnston use it first a lot in her papers. So that's my origin.
Your guru.
Exactly. So the next question is by John O'Neill. Thanks for joining us, John. If a person has a genetic risk for developing a non-communicable disease, so for looking at biomedical information, do you know where or how in the BCIO that information can be subsequently discovered and integrated into the behavioral intervention landscape? And then he put, does the question make sense? I think so, but Janna, I don't know if you can see the questions.
Yeah, no, I get the sense of what this question is aiming at. So basically, we didn't really talk a lot about what makes an individual ontology sort of a unit and what does it cover and what do other ontologies cover and how do different ontologies relate to each other. But there's this implicit concept of a domain or a scope of an ontology. And when we're working in the social and behavioral sciences area, the domain or the scope of our ontologies is focused on social and behavioral topics, largely, aspects that we are interested in as social and behavioral sciences. So we would typically consider something like a genetic disease risk to be out of our scope. This is maybe more in the scope of one of the ontologies that's being developed, in which there are hundreds in the biomedical domain. Now, the question is, okay, but if you happen, nevertheless, despite being a behavioral sciences researcher, to be interested in a subpopulation which is really defined by having a raised risk for one or another genetic disease or some other, or you're interested in the counseling, genetic counseling, which is surely got some behavioral aspects. There's probably 100 different reasons why you might be interested in this particular biomedical thing as a behavioral and social sciences researcher or practitioner. And if you happen to be in that situation, then the answer is simple. You're going to use some content from a biomedical ontology. So you're sort of, okay, you've got majority of content from a behavioral science ontology, but you can also use and adopt content from other ontologies. And these include a whole range of disease ontologies, of genetic ontologies, of whatsoever other clinical aspects of patient presentations and so on. And you're just going to sort of bring that in and use it in your data annotation task in the appropriate place.
I think the most common way to deal with it is really population characteristics, I guess, in behavioral sciences. So I guess in terms of the attributes, that's where you're looking at. But Rachel, thanks for your comment. So yeah, she also said, oh, that's interesting, multiple attributions, possibly, I think, in reference to your response. Or am I getting that wrong?
Edward Thorndike. Rachel says, I have learned that the Jingle Jangle
Fair.
fallacy was named by Edward Thorndike. Do we have a year? Let's pop in I would be curious about when.
Great. Thank you, Rachel, for sharing. Okay, great. I'll mark those as done. Okay, so yeah, this was the other comment that Rachel made. So, oh,
Okay.
interesting. Yeah, multiple attributions possibly, but I don't know in what reference that is.
Okay, so maybe I'll carry on with the next part of the presentation, which is to give a brief overview of the Human Behavior Change project as an application. And of course, the sort of overview includes the development of the behavior change intervention ontology, which is the main ontology of the APRICOT project, among other ontologies that we're working on. But so I'll start with this Human Behavior Change Project Behavior Change Intervention Ontology section. So the objective of the Human Behavior Change Project, which was a Wellcome Trust funded project to PI Susan Mickey over a 5-year period, which I think ended up being 7 years thanks to delays with COVID and other reasons, is to answer variants, to develop a system which was able to support answering variants of the big question. There's loads of big questions in the world, but this is one of them. When it comes to behavior change interventions, what works when compared with what, for what behaviors, how well, for how long, with whom, in what setting, and why? So this is at the heart of, I guess, behavior change science, sort of an understanding, an empirically based, deep understanding of behavior change interventions. And it's fiendishly difficult to answer this kind of question in any real application context. So the behavior change intervention ontology was developed with a kind of conceptual framework, which looks like this, in which you have an intervention in the context of a behavior change intervention scenario. So all of these aspects, the intervention and the outcome and behavior and so on, are all a part of the behavior change intervention scenario. And they are related to and sort of inter-influence each other within this scenario. So a scenario is a specific individual, behavior change intervention context. It's also sort of bound in time and to a specific population, a specific location and setting, and so on. So you have context, which includes which was the actual population, what were some events which happened, like COVID was an event that affected all kind of research going on at that time. Everything had to shift online and stuff like that. You have your intervention, which includes both aspects of the content of the intervention, but also the delivery of the intervention. You have the engagement, which is sort of a relationship between your intervention and your population. How engaged are they? How many of your intended participants did you actually manage to reach? And finally, you have your sort of mechanism of action leading to a potential change in outcome behavior. And sort of sitting on the top of the pyramid here, you have a research study which has some research methods. So we learn about behavior through doing studies. And the whole process of designing the study involves designing and then delivering or producing this scenario, right? And you may have more than one scenario in your study because you might be testing a sort of active ingredient as compared to a control ingredient. So this is the conceptual framework, and this was translated into an upper level of an ontology, which looks like this. So in the blue circles, you have the behavior change intervention scenario and all of the different aspects of it that I mentioned on the previous page, but I will elaborate a little bit more in a second. But then in the red circles, you have aspects of your behavior change intervention evaluation study. So this is a sort of the research side of things. And of course, if you're working in a practice context and you're not doing a sort of study in this traditional sense, you will still have, if you're designing a behavior change intervention and delivering it, you will still have all of these aspects, the blue aspects, because you'll still be designing and delivering a behavior change intervention scenario, but you might not be doing this red part of having a evaluation study and an evaluation report and all of that. Although I guess there are other types of evaluation report than publication in the scientific literature, but you get the point. So here we have our behavior change intervention scenario, and now you'll notice that the arrows connecting the different, so each circle in this schematic is a class in the upper level, so the overall design of the behavior change intervention ontology. And you'll notice that the arrows are labeled, and these are the labels, these are the names of relationships that have been used. So you have relationships such as has parts, that I guess quite kind of intuitive what that means, but then you have some relationships which are less intuitive in what they mean. So has process attribute. This is like something becoming a little bit technical because different classes in the ontology have different core classification as different types of thing. And this means, for example, that a process having a certain attribute is a different kind of relationship to a entity like a human being having some sort of attribute. And I'm not at all going to go into any of the details, just to sort of give you the basic idea that there's a lot of detailed thinking that has to go into the development of an ontology at this scale. And then, of course, also this sort of concept that each of these upper level entities actually has a whole lot of sub entities with more specific elaborations and different classes beneath it. So it's not just one class for behavior change intervention content, but in fact, a whole ontology of behavior change techniques, which fits underneath this one little innocent looking circle here in this diagram. So once you add together all the different elaborations, I think by now the behavior change intervention ontology has upwards of 1,500 classes in it. And as we sort of add or elaborate different aspects of the field, this grows. It only grows. So it's a big endeavor. Okay, so the method of ontology development is to divide the whole domain and the scope of what needs to be done into sub-ontologies. This is essential, otherwise the scope is so big that you immediately go mad. So you have to sort of narrow in on a certain focus and then do that for a bit. And one way of getting started on a particular sub-ontology is to do a survey of existing classification systems that are already used in that domain. Now, your existing classification systems might not be fully ontological, or they might be. I mean, you might have really good existing ontologies. And if that's the case, then great. You can just use that prior work that somebody has done. But even if you've got a sort of partial classification system, which has some of the aspects that you want, but you might have to, for example, elaborate on definitions or add terms to reach the full scope, it's still good to have a starting point. And in the case of the behavior change technique ontology, there was a really good starting point in the form of the behavior change technique taxonomy. This had been built not as a fully fledged ontology, but as a classification of techniques, as a taxonomy, and it served as the starting point for the next steps of development of the behavior change technique ontology. Literature review is essential, determining what are the constructs that have actually been used in that aspect of the domain. You do really need to go and look at what people have published and to think about how what they've published sort of translates into the terms that you have already in the ontology. And this process can be done informally or formally, and in the formal part, which is really an essential aspect of developing an ontology, you really have independent people taking the part of the ontology that has been developed so far and really testing it against the literature by formally annotating the literature with those terms and then checking, how well different people using those annotations actually agreed. Because if there's not much agreement, then you haven't achieved a shared vocabulary at all. If there's not much agreement, you have to go back to your definitions and make them better. The term should also be reviewed by experts, some sort of advisory board or expert community, community of interested and knowledgeable members of the public or the broader research community. And this review step, it can be quite difficult because you have to first bring people along with what you've done and then get this sort of targeted feedback. And finally, it's really important to check the sort of comprehensiveness of what you've done and the usability of what you've done. And testing the usability is again about asking people to use the ontology in specific ways, and then seeing whether they are able to do that. And for this kind of test or evaluation, you sort of rely on how well you've been able to achieve the dual objective of having a really clear and formal system for definitions, but also having definitions that are accessible and usable enough that everybody can, without a lot of training, just jump right in and start using them. And these different objectives pull in opposite directions. And so you can end up in a situation where you've sort of done a really good work at having formal and clear definitions, but nobody understands them anymore. And in case this happens, then you could add what we call an informal definition, which helps sort of people without, that training in that formal way of thinking and writing to understand what is meant by the given class. Yes. So the Human Behavior Change Project also generated and is building and maintaining some tools for using the ontology, such as the BCIO search and visualization tools. These are like websites. The BCIO search is a database which allows you to search content in the BCIO, and the visualization tool allows you to see diagrams which are a bit like this, but automated, so you can get parts of the behavior change intervention ontology as like circles with interconnected arrows showing the relationships. We also have a prediction tool, which I will mention in a subsequent part of the presentation, so I don't go into it now. A theory database. This is a slightly separate project which involves formalizing behavior change theories and then annotating those to the ontology. And finally, there is a kind of study findings and research browser tool. Okay, so the ultimate goal of the Human Behavior Change Project was that if all published literature used the shared vocabulary as provided in the BCIO and other ontologies where relevant, we could build up a knowledge base which allowed us to automatically answer the big question, which you saw before. So I won't read it again. Instead of relatively small knowledge silos, we need large joined up data sets and theories and shared language that cut across topics, disciplines, cultures, and countries, and which integrate evidence from many disciplines, e.g., psychological science, anthropology, sociology, etc., etc. So these disciplines are often separated by different theoretical frameworks, different languages, like in the specific details. I mean, I'll never forget when I saw the difference in language between neuroscience and psychology, and it's like, hang on a second. And then there were whole fields that called themselves like neuropsychology. And I was like, what is that? It's solving by concatenation, the sort of fundamental divides between these different disciplines. But leaving that aside, the idea is that you should be able to determine relevant insights from an adjacent field and bring them sort of into the same knowledge base, the same sort of aggregated knowledge base. All right. So to have all the literature annotated in this way is a very, very far from where we are at the moment. The Human Behavior Change Project, as I could mention a few slides down, annotated a large corpus of articles about smoking cessation interventions and a somewhat smaller corpus of articles about physical activity interventions. But these two corpora were in the order of hundreds of articles, whereas we have thousands and thousands and thousands in our, hundreds of thousands in our wish list. And to get all of this information into the same knowledge base, if we did it manually, would be a completely prohibitive amount of work. So there's no chance that we would be able to do it without automation. And this automation doesn't yet fully exist. Within the context of the Human Behavior Change Project, some methods of automation were investigated and they were found at that time to be not good enough. These days, for automatically annotating research articles with ontologies in order to sort of automate the structured extraction of knowledge, we have much better tools. We have language models which are kind of good at this kind of task, but it's still, some research is still needed in order to apply the models to workflows with the ontologies that we have and check and validate that they really do it. And there's some domains where it works well and others where it doesn't work so well, even with the most performant and powerful language models. We also need to increase ontology adoption because the more people directly use the ontology, the more people sort of think in advance of how their research could be fit into this shared vocabulary, the less you need to retrieve after the fact with automation approaches. So these sort of objectives are part of the motivation for the currently ongoing APRICOT project. We have another break for questions now. Do we have more questions at this moment?
So we have one previous question, which was basically suggesting, well, the person was wondering whether we can call the ontology a standardized behavioral language.
Yeah, I think so. I think that would probably be not a great strategy because we want to make exactly a distinction between language where we don't want to force people to use exactly the same words and this process of standardizing around definitions and meanings. And sometimes it's helpful to have a word like ontology, which nobody uses ordinarily, to sort of pick out a really different thing that you're trying to do. Whereas language is one of those words that gets used in a million different ways. So yeah, I think it is an awkward word, but maybe I'm personally quite biased on this question.
I think we've also become maybe more aware of trying to work towards consensus over time. But obviously, in psychology or in behavioral and social sciences, language is used very inconsistently, and sometimes for good reasons. Sometimes certain research groups prefer labeling things a certain way. But I think what Jana was saying with it's really more about making differences explicit through definitions. And then whether you want to call something one thing or another is another question. So in ontologies, we can also have synonyms, for instance, where we record different uses of a word that can have that meaning. But it's really sort of the definitions that we try to make people focus on, and then that class has a unique ID. So you know exactly what definition goes with what class. So the labels I find sometimes obviously useful, but you really want to focus on the definition.
Yeah, this sort of idea that we try to make language secondary in a way.
Yeah, almost there. But thank you for the question. Are there any other questions? And if people, I know that you can't seem to really use the chat, and I will amend that in the next webinars. But if you can find the Q&A section, just post your comments or questions there. Any feedback is very welcome as well. We're really very willing to respond to anything. But yeah, I'll leave it back to you then. Oh, Marta, did you want to jump in?
No, just joining the discussion if useful.
Yeah. So we definitely we have a few more slides, but I think the idea was to have quite a lot of time reserved for comments, questions, discussion, and really just to have that steered by you, the audience. So yeah, feel free to jump in. So maybe I'll just push through the last few slides in the next 10 minutes, and then we can have continued open discussion, and let's see where it takes us. So thanks. All right, so I mentioned that I would talk more about the prediction tool as a sort of outcome of the Human Behavior Change Project. And this and the automation aspects. So the idea that you can use ontologies to sort of code or annotate systematically data, and that this can then be used for various downstream automations. I mentioned already this sort of the Human Behavior Change Project, the effort to automate data extraction didn't work that well at that point, but now we're working on newer approaches. So watch this space. But the what was maybe more of a success story was using the data that we had annotated in order to do predictions based on the ontology and kind of automation or machine learning algorithms. So I'll talk a little bit about this. The objective was not only to find information on scenarios that have already been tested, so not a sort of, okay, what has been studied in the literature, but really to be able to take that knowledge of what has been studied and go beyond it to make predictions about novel scenarios. So the paper that I'm reporting some results from is this one here, predicting outcomes of smoking cessation interventions in novel scenarios using. So the abstract prediction task that we wanted to address here is if you've got some structured data and text about interventions, predict the intervention outcomes. So we've got a sort of description of an intervention which is hypothetical. And based on the past literature and the results that have already been found, we want to use this hypothetical description to be able to predict intervention outcome. Now, of course, this predicted outcome might not be fully accurate. In fact, it cannot be fully accurate. But you can imagine what a powerful tool this is for informing the design and the development of future interventions. If you have some idea of what the evidence suggests would be the outcome under different scenarios. So the data set which we used was based on ontology-based annotation of study reports. And just as a reminder to sort of understand this concept of ontology-based annotation, you have some text. And in your text, you have described various attributes of your intervention. The text comes from the publication of a study report. And it may have attributes like that there were face-to-face visits, and this attributes could be formally coded up using the ontology, in this case, the mode of delivery ontology, which includes face-to-face mode of delivery. Mention of a smartphone app could be annotated as mobile digital device mode of delivery. And so on for all of the different attributes that are relevant in a study, and noting that you have different types of annotation that you might be making. These are sort of presence absence, so presence of face-to-face delivery, presence of mobile digital device delivery, but some other annotations might be sort of not only whether or not a certain feature was present, but also that that feature has a value attached to it, like a quantitative value. So this number of participants, 105, would be a quantitative extracted value. The sort of underlying data set, as I mentioned, were published reports, and these published reports were of smoking cessation trials. So actual trials of smoking cessation interventions, and where the outcomes could be comparable in some sense. So they were proper clinical trials of smoking cessation interventions where the smoking cessation outcome was formally defined and captured. Not only positive trials, also negative findings were in scope. And this smoking cessation data set, it ultimately involved around 450 papers. So, and that was a huge manual annotation work. And this manually annotated gold standard went sort of into the ontology as the organizing structure, and from the ontology, 700 classes were used. Okay, so I talked before about the difference between black box models and transparent models, and what we wanted was a model which we could learn from the data, the trial data that had been extracted, but which would be transparent. So we sort of settled on a system which was based on rules. Rules are transparent and naturally interpretable, and you can easily integrate them with ontologies. But traditional rules systems are unfortunately not, you can't, in traditional rule systems, you're not sort of conditioned on a learning system from data. So usually not trainable, and they require sort of binary features as input. So we built our own rule system, and I'm not going to explain this slide. I just leave it with you as a picture which explains itself, right? So the system basically induces from the data a system of rules where you have conditioned the rules on the data in such a way that you can train the system. And you have multiple rules for each prediction. So your system combines and produces a predicted outcome as a sum of different rules which were conditioned based on the data. So this is an explainable system. It's completely transparent in the end, but the weights, or how much the rules apply and what their sort of impact is on the predicted outcome, this is conditioned on the data. And this system was shown to be somewhat more performant than several other approaches which you might use in such a prediction problem, such as having a decision tree or having a deep neural network. And in addition to being at least as performant as other approaches, it was also somehow more explainable. Okay, I'll skip that part. So the results of this were implemented into an online tool, a prediction tool, which is available at, that should say PRED at the bottom there, pred.hbcptools.org. So maybe somebody will put the link into the chat for everybody because it doesn't quite show as it should on the screen. But there the system allows you to specify your parameters of your intervention and potential intervention components and get out a prediction, which is based on this hypothetical scenario, but also based on the evidence. Another completely different application is to use ontologies directly for decision support. So here you have a kind of strategy in which you capture the knowledge you need inside the ontology in order to make recommendations. And the motivation for doing this is to sort of reduce into individual variability that you get when humans are making decisions directly, but to avoid the sort of intransparence of other modern AI algorithms. So you have something where you're completely transparent and based on knowledge, and nevertheless automated, and sort of you can define it in an unbiased way. So using ontologies takes something like the form of a decision tree, but you can tie the decision tree directly to the categories and aspects and attributes of your domain in the way that you've captured them in the ontology, and it enables a kind of automated reasoning around that. Some examples which are not directly relevant to behavioral sciences are, for example, suggesting diagnosis based on symptoms. By the way, this kind of knowledge-driven decision support is widely used in clinical contexts. So here's more of this kind of medical or clinical example. And here is an example which unfortunately Maya, who couldn't be here with us today, would have presented herself. So I'm going to skip through it and just leave you with the idea to read this awesome paper, Development and Evaluation of the Contextualized and Personalized Physical Activity and Exercise Recommendation Ontology. And in this study, what they did was they specified a physical activity ontology and sort of tied it to contextualized personal attributes and used that to support decision recommendations for action plans and for coping plans for physical activity. And I think this is truly awesome work, and it's a pity that Maya was not able to join us today in order to present this work, but I won't be able to do justice to presenting it, so I just leave you with this paper. And yeah, I think maybe we could carry on for the last part with our questions and discussion. Let me just jump to the reflections and conclusion. So there we go. Comments, questions. Community of practice activities planned, and please let's have some discussion now.
Great. So I'll start with the questions again, but Marta or Carolina, did you want to maybe just remind people of kind of the next things that we have planned as well, or should we do that towards the end?
It's fine. I can remind first, and then we move to the Q&A. So for those of you that weren't here at the beginning, this is the list of activities that we have planned for the first year. Most of them already have dates, and you will receive more information about these activities through the community of practice. Janna, can you just put the next slide, please? Also, if you have ideas you want to submit in terms of ontologies that you are developing, for example, for which you would like feedback, your work and your idea can also be featured in the work spotlight, one of the components of the community of practice. And the idea is really to have informal sessions of discussion and feedback on the use of ontologies and development of ontologies. So if you're interested, you can just sign up using the QR code. The links to join the community of practice are already in the chat. if you are interested in joining, if you haven't joined yet. And I think now we can move to the Q&A, have some time for that before we close the webinar. And thanks, Janna, for the amazing presentation.
Yeah, thank you. Okay, so the first question slash comment is from Rachel Wood. So she's saying that her research is very focused on attachment theory. Last that I looked, and she was one of the BCIO user research participants. Thank you for doing that. It wasn't in the ontology. Is there any plans for this? Many thanks. Jenna, if you want to, actually, I can take this one.
Yes, please.
Yeah, so basically when developing the mechanism of action ontology, which is one of the lower level ontologies as part of the BCIO, we do have some concepts around attachment or relationships, but this is indeed not very developed. So there's some theory mapping work that's going on where we might be better able to capture some of these constructs. But if anything is missing, I do want to say that ontologies are evolving frameworks, so we're maintaining those. So you can also submit any issues. So if you're saying that the theoretical constructs are missing from the ontology, you can notify us and we will respond to those issues on GitHub. And I'll add the link to how or where you can submit your issues in the chat in a bit. But yeah, thank you for that question. So
yeah, and just to sort of add to that, I think it's the idea is very much that BCIO transitions to being a user-driven, evolving and growing entity, just as the gene ontology and other successful ontologies are. It's not, entirely up to the team of researchers to come up with where the ontology needs to go and what aspects it needs to cover, but also up to you, our wonderful users.
Can I also add to that? That's one of the reasons why we created a community of practice. It's also to provide training and support and collaboration to researchers wanting to develop their own ontologies or extend the existing BCIO. So as Janna said, this is really community building. And what we hope in the future is that many of you will be leading work on developing ontologies for different behaviors and contexts.
And the link was actually added by Michaela, who was a lot faster than me, so thanks, Mika. So we have a comment from Sophia just saying that it's a very useful seminar and they're looking forward to the next one, so thank you. One anonymous attendee is commenting or asking, would the use of ontologies also mean the use of commonly agreed measurements, since we would be looking at the same behaviors? It's a very good question.
Yeah, this is a really good question. So it's not, it doesn't necessarily imply that you're using commonly agreed measures, only from our perspective that the measures that you're using can be mapped to the shared ontologies sort of is the requirement. But I think there's a lot to be said for commonly agreed measurements as well. And in fact, there's a sort of research methods branch of the ontology, which is concerned with this. I don't know if one of you want to talk to that a bit.
So,
pity that Maya wasn't with us,
yes,
unfortunately,
absolutely.
because she would have been the one to answer this question in a more detailed way.
Absolutely. So I think one of the biggest challenges is really that we don't really have agreed measurements. I don't think an ontology can necessarily resolve that. What we can do is organize the measurements that we have in the literature more and link them to specific constructs. And then we would, of course, as researchers, need to verify whether these are good measurements for the specific behavior or construct. So that's one way in which the ontology can serve as an organizing framework to help synthesize existing knowledge and help us sort of refine it iteratively. So that's what I would say about that, maybe. But yeah, an interesting thing is also obviously you can have different types of measurements for the same behavior. So an ontology could also kind of signpost you to the different types of measurements that exist. But that work would need to still be done, and that's a lot of work. So I don't know how far or how fast we'll get there. But Marta, I think you wanted to add something as well.
Yeah, I was just going to say that for physical activity, for example, as we are developing the annotation schema, we are annotating and identifying different types of assessment, like more objective, more subjective, questionnaire, pedometers, those kind of elements. And when coding that in the papers, there is a link to the specific measure that is used. So as Paulina was saying, we can definitely identify most frequently used measures, and we can help to improve agreement on the constructs that need to be measured or elements that need to be measured, but not on the specific questionnaires or surveys or specific types of digital models that can be used to evaluate. But there are some groups actually working on that, on standardizing measures and agreement on measures for different types of behaviors.
Thank you so much again. So next we have a question from John. So to what extent could all unique BCIO elements have a corollary in the DBMS fields that hold the evidence base? And to what extent can it ever be possible to generate new intervention evidence that is generated or captured to be ingested without further human manipulation? So for instance, can rigorous application of ontologies make it simpler to build on existing evidence and also to add to it in real time for policymakers to make decisions? And sorry, go ahead, Janna.
No. I think so this is, on the one hand, there's a dream here. We're sort of working towards a world in which evidence can be useful immediately as soon as it's available. And we're very far from that world at the moment. At the moment, it takes years for new evidence to have any kind of impact, usually on policy or practice in any real tangible way. And so we're working towards this world where, because we have structured ontologies covering all aspects of a study, and because we have this kind of knowledge bases in which we're ingesting the information, any one piece of evidence that appears will be able to be ingested without much effort, maybe with a human in the loop automation approach where it sort of comes up, hey, there's been a new study, we think it's relevant, and here's the pre-filled structured form of the results, and the human sort of checks that through and says, yes, this looks good, bring it in. And then immediately the sort of recommendations are updated to use that evidence. We're very far from that world, but that's the vision that we're working towards.
Thank you, Janna. Okay, so next we have Mark Coben, who asked, at what threshold do you feel comfortable in making predictions using a BCI ontology, given the context-specific nature of many behavioral interventions and publication bias? He goes on to give an example, but I'll maybe stop there so that you can respond to it first, and then we can elaborate further.
Yeah. So I think part of what we want to do is sort of improve the structured specification of those contextual attributes and really figure out in which ways context is driving variability and in which ways it isn't driving variability, so that we would be able to have a much clearer and more empirical way of saying this particular intervention, well, we can't tell how it's going to impact that population because we see a huge variability depending on, these sort of aspects. But this other intervention is fairly consistent across these different settings, and we feel fairly confident that that intervention is going to have the effect you desire. So a way of narrowing in on this heterogeneity problem and at least carving up the areas where it's worse and the areas where it's more manageable, which we don't really have a handle on at the moment because most intervention sort of descriptions don't give enough information about contextual variables in the report to allow us to build up that knowledge base. So context is very, very important to the whole BCIO effort, and sort of trying to get more formal and structured about those contexts as well as just about the intervention attributes. Now, in terms of the example, I think this would be an example of a sort of mediator that when you're providing information about risk to a population, some of whom have maybe a higher risk, some of whom have maybe a less high risk, you would expect that that information would impact different people in very different ways. And you could have a whole theory about that. And we wouldn't want to abstract from that. We wouldn't want to sort of take out the differences from the anticipated impacts there. I don't know, Marta, have you helped me here? Have you got words of wisdom for us?
Not really. I think that you have mentioned most of it, so I don't know if I have anything to add, to be honest on that.
Okay. Well, thank you. Thank you both. So we can move on to the next question, which was by Paul. So he asks, well, the ontology is about BCIs, so behavior change interventions, which ontology provides a good shared understanding of behavior and directly related concepts as used in different and other contexts. So
Yeah.
we can probably signpost you guys to the human behavior ontology, which is one of our lower level ontologies, part of the broader BCIO. So that one would be most useful for specifying behaviors and aspects of behavior.
Also just to say that the human behavior ontology, although it is part of the BCIO, it specifies categories related with human behaviors that apply to other types of interventions. So there are, I think this element is important, there are sub-ontologies or lower level ontologies and components of those that go beyond behavior change interventions, so that can be used to classify other types of interventions or use
Or
them
outside of
for studies.
interventions
Yeah,
at all,
exactly.
right? So observational evidence of different types, or
Exactly.
even for applications outside of intervention sort of studies altogether, such as practical applications.
Brilliant, thank you. And then I think we can maybe do the last question before we wrap up. So this is from Stephen. So the question is, are there any parallel efforts that are treating the group as the unit of analysis rather than the individual?
Yeah. So I think this is a really interesting and important observation. So the BCIO is not only focused on the individual, although I would say that maybe the majority of the content is more individual oriented. The idea is to also include those units of analysis that are more societal or population level, or interventions where there are no specific individuals involved. And we do have in the population ontology a layer which is all about population attributes that cannot be reduced or somehow translated into individual level attributes. And there's certainly would be behavior change techniques, which are more oriented to population level interventions. There probably are similar subgroupings in other ontologies, which may be worth.
Yeah, I think this is a really good point, something for us to consider also. When we publish the ontologies, there's always like comments and notes related with the different ontologies. And this is really useful feedback because this is the kind of thing that we can make more clear in terms of what applies to groups, individual populations, what is the kind of work that still needs to be done on that. So thanks for that comment and question.
Yeah.
Just to add maybe to what Janna was saying as well, I think we're reflecting what often happens in our field. So we are often more individually focused. So that's why the entities that we have or represent are sort of more individually focused as well. One thing I should mention as well, that there is a lot of work on dyadic interventions as well, which is interesting, where people are trying to specify behavior change techniques around that more. But definitely, as Marta said as well, we can do more work on being clear and also just signposting people better on which classes are group relevant as well.
And adding more content that comes out of this important direction
Exactly.
of research.
Absolutely. Okay, those were actually all our questions.
And
Okay,
we're at time.
In time, exactly. Thank you, Janna, again for your availability. I think it was a really important topic for our first webinar to introduce ontologies and how we are working with ontologies. This sets the stage for the series of webinars that we will have throughout the year. Thank you, Paulina, Carolina, Michaela, for the help. Carolina is our community of practice boss. So she's the one to go to when you have questions and you need support, and she's really the main person dedicating her time to this. Thank you everyone who attended the webinar today. We are really look forward to seeing you in other events and continue to interact through the Community of Practice platform. Thank you. Bye-bye.